Okay, everyone. Hi. Things have been. It has really been a while. I've come to share stuff with us here, and I'm back again. I've been so busy. It has been full of work. Even today, I had an interview. I had an interview with OGTV. That's where I am in Ogun State, in Abeokuta. So I had an interview as a software expert. So I was invited to come and speak on my career, and how I'm joining in tech, and how I'm here. Giving my achievements, my contribution, and my impact actually, and how I'm able to contribute to the advancement of the industry. So it was a whole lot. It was a lot of. I think you should just go and watch it on OGTV. It was a whole lot. I had an amazing session with the host. It was so awesome. So today, we'll continue on. Like I said, I'm going to be giving us the outline. We continue on the software engineering overview of everything we'll be talking about in this course, right? So I've broken it down into about module 5, module 6. This one is module 6. I've broken into about 8 modules for now. Module 7 and module 8 is like the last one. Module 8 will be like the whole. We'll now be talking about writing of code, setting up a project, and doing something very simple. Not really simple, but something that will make us have an experience on how software engineering. From top to bottom, we're gonna do a lot. We're gonna do the top to bottom. We're gonna draft out our requirements and this and that. So today, let's just make it starts, right? So like I said, software engineering review. We'll be having module. The first module is like foundation of software engineering. We're going to be talking about foundation of software engineering, and I broke it down to this. I have introduction to software engineering. We're going to be defining what a software engineer does, what software engineering is, and all. And then we'll be doing software development lifecycle. We're talking about SDLC, that's software development lifecycle, where we have so we have the what's it called? So we have the research. You're going to carry out research phase. To know about the software or what you want to build. That's like the research. Research is like also like I call it requirement gathering. So you gather requirement gathering. You understand? So you do requirement gathering. After you understand requirement gathering, then you map out. Okay, now you done requirement gathering and seeing the feasibility. On that requirement gathering, you're still going to be doing like something like feasibility study. So feasibility study is like you seeing, what you want to build, does it really worth it or not? Then after all that, you start, you look at what resources you have available. How many engineers you have, or how many people can get on the project and start it. Then you now start like, after you've done your resource mapping also, then you start with that's the coding. Like you jump into implementation. So you jump into implementation is done. Then after implementation, done with everything with implementation, you need to do what we call testing. And testing, once you are done with testing, you then deploy. Once you test, you need to deploy. So testing phase can be your unit test, integration test, CS, continuous integration test, and continuous development test, right? So you're going to be doing all that CI/CD. Then you do your deploy. Once you deploy, you're ready to go to production and ready to give it to your end users. Then after that, like I said, you deploy, and after you deploy, you monitor, because you want to monitor your system. So you have to monitor the system. You monitor how the system is performing. If there's any issue, you can report. So monitor it. If there's any issue, you report, or if there's any performance issue, you report. Then you also do. So there are sometimes you might want to add more feature, right? You can continue to add feature. You continue through the phase again, through the process. And last is actually when you want to decommission a project. Decommission is like you are sign up on the project will not be supported, or the end of life. We call it end of life. So the end of life, like you're no more coding, you're no more giving support and everything and all. So you can imagine you using a version 1 of the product, and they're already building version 2. So for those of you that are already using version 1, for example, those of you that are already using version 1 will not be supported again. So they'll just tell you, we're not supporting version 1, you need to move to version 2. So the reason why I think that maybe they have some issues with that, or they have more advanced feature or more robust system than the V1. so they will decommission that one. So that's why you see, maybe for example, your WhatsApp is not working again. Maybe you have an older version. They're going to decommission the older version and get to a newer version, right? So that's it. And yeah, so support will end on it. Anything support, anything issue resolution, they will not be giving us. That's what end of life is all about. Then we move to software processes. We're going to talk about waterfall. We're going to talk about spiral. We're going to talk about agile. We have different. We are in agile. We have the Scrum and the Kanban. We're going to talk about that. Then the DevOps. So DevOps is also part of the software processes, right? Like I mentioned in the SDLC, I mentioned it in there. So we're going to be talking about that. So project planning and estimation. I mentioned that when I was talking about requirement gathering and research. So I'm going to talk about your project plan. You're going to plan the project, plan it very, very well, resource everything that you need to do. You need to make that project come to life. If it comes to money also, you need to plan it. So, and we talk about estimation. Estimation is like you giving a timeline of when the project will be completed. You understand? You're going to give a timeline, and this timeline, you're going to break a lot of your tasks into smaller units. And you're going to group them. For those that are supposed to be completed together, group them together. For those that will complete later, you can put them in your backlog. So you are going to estimate then how long you need to complete and what you need to get to the market if you want to get to the market as soon as possible. All right. So in module 2, we're going to talk about requirement engineering. It's still part of all the requirement stuff, right? We're going to talk about requirement engineering where we have functional and non-functional requirements. Functional requirements are what the system needs to work. Yeah, that's functional requirement. And non-functional requirement, like what it can be what rules or guidelines or laws that need to be guiding the system that will make the system to make sure it works and is efficient. Scalability is part of it. Scalability, availability. When you are saying the system is available, it is not available, or is available. That's part of non-functional requirements, or maybe following some security standards. Those are not functional requirements. Those are laws or rules that guide the product you are building, and all. Then we move to it's still part of it. You can imagine I'm very much explain all this on here. We're going to talk about requirement gathering, which I've already mentioned here, right? You're going to do requirement gathering analysis. Like I said, analyze the requirements, do your feasibility study. Does it worth it and all? Do we need to go into this? What do we need to put in place? What stuff we need to get? We need to get some licensing before we will start the project, because there are some projects you will build that requires you even to have a license. Imagine you're building a banking application and you don't have a license. You're going to get sanctioned, so you don't want to do that. All right, so we'll move to use cases and user story. We're going to talk about the use cases. So use cases what are the cases that users can try to do, or what are the part of things that they can do in the system. So we can map out the use cases, what the user need to do, what they can do. So that will actually give you an overview of how you need to build the system. So you need to map out those use cases out so that to really guide the system and you use the stories. And then so we're gonna so you can tell the story of how the user can interact with the system, what the user need to do before you get here, before you get to A, get to B, get to C. So map out the story also, so that when you map out these stories, it will actually help developers to build a more efficient system, because that will really guide you. Because when you have a story already and then you as a project manager, for example, you've done the use case and the user story and you give it to a developer to build, and the developer okay with what you are saying, because everything you're going to be building will be guided by what has been defined already. What has been defined already, so that you don't drift away from the original focus of what you're supposed to do or how the system is supposed to work. Then we'll talk about requirement documentation and validation. You need to document your requirements, and validate those requirements also. Are they valid? Are this requirement even valid in the system? Are they supposed to be there? Are they supposed to be part of the requirements that you're talking about? So that's all on that. Okay. So like I said, so that's that on that. So like I said, requirements, documentation, and validate the requirements. Ensure that requirements are valid. Ensure the requirements are visible. Ensure the requirements are visible. So you don't want to do feasible. You don't want to do a system, or you don't want to how do you want to put this? You don't want to build a system that is not feasible. I mean, imagine I want to build a system build a software system that will how do I call it, collapse building. Is that not funny? Build a software system that will collapse in building. Yeah, it's possible. It's possible that you can build such system. It's possible, but you're going to look at, is it really feasible for me to do this? To build ordinary software, no machinery, nothing. You just build a software that will just, I mean, maybe in the future you can have a software that you just press enter and building will start collapsing. Maybe we can have that. Yeah, it's possible. I mean, maybe you can connect to, for example, maybe except you plant dangerous things in the building, and then when you activate it to collapse, or without anything it's communicating to, only the software system just pressing the button and you expect the building to collapse. I mean, that's not feasible anyway. So you need to make sure you conduct feasibility studies. Feasibility study is also part of it, and you also make sure that, I mean, during the validation process, you also make sure that the software you are building is testable, because that's very, very important, right? Then we'll move to software designs, right? Software designs here. So we'll move to software design. So this software design, we're going to be talking about principle of software designs. Principle of software design. So principle that guides software design, we have the solid principle. The solid means single, that's the S. The S means single, right? Single responsibility of design. That's what the S means. Then O means open close principle. Open close principle. Then the L means Likov's substitution principle. And then we have the I. The I means interface segregation. And we have the D. The D means dependency inversion. I mean, so let me even start with the D. So imagine you're building a software system and you are tightly coupling the whole component of the system together, which means you imagine you want to we're going to talk about a lot, we're going to talk about object and all. So but let me just give you an abstract overview of what I'm trying to say in this D. So you want to build, like, let's say a class, right? A class that depends on other parts, right? And the other part it depends on the actual implementation. So it's actually the implementation of. Okay, so let's say you have a class called students, and it depends on another class called school, and that school is not really an interface. So that's really an actual implementation. So let's say the school is like Ikeja Grammar School, right? So which means before you can create a student, it has to be Ikeja Grammar School. You have to create a student, which is not true, because you can have many schools. You understand? So you can have different kind of schools, right? So that school will be like, because the student can actually change school, right? So if the student is trying to change school, I mean, you wouldn't want to have like the student belong to one school, because the student can change school. You can imagine when you were growing up, you went to primary school, it's a school. You went to secondary school, it's a school. You went to university level, and then you go to a master's, which can be different schools, right? So imagine you're just tying yourself down to Ikeja Grammar School as one school, right? You can't. So if you want to create that student, let's say you want to create the student, which is an object. You want to create an object of student. You have to pass Ikeja Grammar School, and you don't want that, right? So what diversity inversion is telling us is a class should actually depend on abstraction, not concrete implementation, right? It should depend on what? Abstraction. So the abstraction means you're going to use something like an interface. You're going to talk about that interface or an abstract class, right? Let it depend on highest level of abstraction, not actually a concrete implementation. Because if it depends on abstraction called school as a student, so you have a class called user student, and you have an abstraction, for example, an interface called school, right? So you can create any version of schools and give it to the student you're creating. So that is what dependency inversion is trying to say. Then we have the interface and segregation. Segregation, you need to group all similar components of what that interface should be doing, group them together. So you shouldn't have like create user and you're not having process transaction in create user. So that is actually going against it. So interface segregation is make sure that all the abstract methods you are having in the interface, right, are all of similar things. I mean, they are all working to achieve one aim, right? You understand? So that's what I was saying. And then it also states that you should have your interface should not be that long. It should be like, it should be very simple and short, right? Simple and short and very, very descriptive. Then we have the legal substitution principle. We're going to also explain that. Then we have the open close principle. We also need to explain that. Single responsibility of design also need to explain that. Remember, single responsibility of design is when you have. So let's imagine you have a particular. We're going to be talking about those classes. I'm talking about a class that creates, what it does is just create customer alone. It doesn't do anything about create customer. That is what single responsibility of design is doing, right? It's just create customer. It can create customer in different way. It can create customer from another business, create customer from the, but remember the objective is what? Create customer. So that's what single responsibility of design, only designed to do one thing and nothing else. But if you are not putting like something like delete customer, then that's going against it, because it's not a single responsibility of design, because you're not doing something else. Delete customer, update customer, you are going against it. So single responsibility of design is one thing and nothing else, right? And single responsibility of design is actually also being applied in. We're going to be talking about CQRS, right? That is, we have the command query responsibility segregation. So this single responsibility of design is also applied in here. So we also applied there. And the open close principle also means that when you have a class that does one thing before, but you want to implement another thing, so what you need to do is it is closed. It is actually closed for extension, but you can open it is closed for modification rather, but it's open for extension, which means you can extend it, but you don't need to modify it. So that's what open close principle is saying. So a class should be open for extension, but it should be closed for modification, right? So now let's even talk about what's it called? I explained something called single responsibility of design. You can imagine the single responsibility of design. What it's doing was creating customer, right? So now imagine you want to add something like let's say like process transaction. You are already, even though you want to use something from the class, you need to just extend the class and then create another class that you can reuse those other property in the other class that you want to update before. But meanwhile, you shouldn't. That's what the open close principle is saying. Open for extension, but close for modification, right? So that's that. And legal substitution principle. Remember, legal substitution principle is saying, so let's assume you have like an interface A, then you have actual implementation B and C. These B and C, they implemented interface A, right? Which means wherever you want to create an object of interface A, you can either use B or C without even breaking implementation. Which means whenever you use B or C that are that implement A, that's interface A, the code should not break. It should still continue to work the way it works. That's the simple definition of the legal substitution principle. Alright, so then we will then move to design patterns. We're going to talk about design pattern. I'm going to talk about gang of four design pattern. There's behavioral design pattern. There's behavioral design pattern. There's behavior. There's creational design pattern. There's structural design pattern. Structural design pattern. Yeah. So we're going to be discussing all that. Yeah. Behavioral. You can have something like the observable is part of it. Observable states. All these are what are behavioral design pattern, right? So we have the creational. You have this. You have the abstract factory. You have this or that, and you have the structural design pattern. So all of this we are going to be talking about in this course. Yeah, very close already. Then we will move to UML. We'll move to UML, right? So I'm going to be moving to UML. So UML, UML design, that's universal modeling language. So this under this UML, we'll be talking about activity diagram, use case diagram, all sort of diagram, activity diagram, sequence diagram. We'll talk about sequence diagram also, sequence diagram, and a whole lot more in there. And all the modeling tools, we have the visual. Visual is actually a modeling tool. Actually, the visual, we have the Lucid chart, we have the Escali draw, and a lot of modeling too. Then we have the architectural style. So we're going to talk about architectural style also. We're talking about monolithic and microservice and event-driven architecture. Talking about event-driven architecture. So under and also when we are getting to system architecture in software, like we're going to talk about both system architecture and product architecture. Those are actually some design system design interview. So some questions can be like you need to apply system architecture pattern, or you want to apply product architecture pattern. So all that will be explaining in our course, right? So that's also for programming and implementation. We're going to be talking about coding standards and best practices. So how you need to code well. Like we're going to be talking about code. So we're getting to coding. So we're going to be talking about programming languages. We're going to be talking about Java, Python, JavaScript, right? Programming languages, Java, Python, and their coding standard, right? What are you need to understand about primitive, non-primitive, object, class, and a lot of them. Trading, understand the garbage collector, understanding the principle of some programming languages, the four corner principle of some programming languages like Java. Like we have the OOP, object programming language. So OOP, like we have object oriented programming language. So they have some principles that guide them. They have the abstract, the inheritance, the encapsulation, the polymorphism, and the abstraction. So we're going to be talking about all those pillar of OOP, so it's object oriented language. So we'll be using Java here. We're using Java to explain all that in details. We'll be explaining all that in details. Then we'll move to version control. We'll talk about Git and GitHub, and write some code, and then we'll learn how to use Git and GitHub. I will explain all that in details. And we'll explain about secure coding. When you are coding, you want to make sure that your code are very secure, right? They're very, very secure. And how do you write secure code? All that we're going to be explaining, because you are not just going to be writing any kind of code. You don't want a code that an hacker can find some weaknesses in the code and then penetrate into the system, and then you might lose money, and then you don't want that. Even in some banking applications, most of our code are very, very secure, right? Very, very secure. You can before you can even try to get in the system, you have known what to do. So secure code is very, very, very good. So, you need to understand what secure coding means. And how you need to code well, right? Then we move to some design, some designs, like some software designs like 3D. That's stress-driven design, where you write test before writing actual implementation. Then we have the domain using the design pattern. This domain using the design pattern, we're going to explain that too in details. How you have the domain expert and the software engineer. So both of them actually work hand in hand together to make sure that the what needs to be done or what needs to be built is very, very understood. So there are some special patterns in domain. So we're going to be applying a lot of what we have learned. For example, this CQRS. That's command query responsibility segregation. We're going to be using a lot in the domain design pattern. For example, we have like use cases. Use cases actually exist in domain design pattern. So for example, we now have command. So command is like we want to create a user, right? So You understand? So you're going to use, you're going to have an understanding that you have from this, you apply it here. You apply a lot of engineering principle, you understand? CQRS, solid principle, you're going to apply it here. You understand? So that is very, very important for us to also learn. Then we'll move to software testing. It's very, very important. Let me put it that way. It's very, very important to make sure you are building a software that can be tested. I mean, you just don't want to build a system that can't be tested. You need to build a system that can be tested. Very important. We're talking about that. That's software testing. So we're talking about levels of software testing. We'll talk about levels of software testing. We'll talk about test automation and frameworks. We'll talk about that. And we'll do so when you write all those tests, we'll talk about continuous integration and continuous deployment. So when you're writing text and you want to make sure that your deployments are ready, are production ready, you need to make sure that, I mean, these two are running. Continuous integration, you're continuing, I mean, writing your code and pushing and deploy and the continuous deployment, and the code you are deploying is being tested, ready for production, and then deployed without any issue. I mean, constant testing. The testing is running as I'm making changes. So all that's very, very important in software testing. So quality assurance and metrics. Also, we will talk about that. Then we'll talk about software projects management module. We have, which I've explained some of them here, the Agile module, the Scrum and Kanban methodologies, and we have the risk management management in software. And we'll talk about team collaboration and tools, because when you are done with this course and then you probably find a job, you will collaborate with team members. You collaborate with team, and you need to learn some of the tools that you use. The Jira is part of it. You have Jira and Trello. There's Jira and Trello, and there's Linear. There's another one called Linear. Linear is also very good. Linear. So these are team collaboration tool where you have tasks, share your tasks as issue, they will report it from there, and then you need to fix it, right? Then we'll talk about documentation and reporting. You need to document your project, document your software system. Documentation is very, very important. Let me come again. Documentation is very, very important. So I'm going to give you one example. So I recently contributed to Kafka. That Kafka is an event-driven architecture framework. It's a framework, right? So I recently contributed to it, and my contribution was on documentation. So there was this code that was written. The code was not really clear. So when you are reading as a software person, you can't really understand until you go deeper into the code, and then you understand. So I found that issue, right? And what I did, I made sure the code was properly documented, because I understood the code and I don't want other developers to struggle while reading the code. So I documented the code, and voila, it was approved, it was merged, and the code maintainer appreciated my contribution. So documentation is very, very important. Documentation is what? Very, very important. You understand? It's very, very important, because it will make other developers to understand the intention of what the code is supposed to do, right? The intention of what the code is supposed to do, right? And so sometimes when you're writing code and you don't have documentation, you might even be questioning yourself, like, why did I write this thing? How come? But when you write documentation, you can come back to the code and understand, okay, this is the intention I'm trying to, because you can forget the intention of the code. You can forget. Imagine I wrote the software like 2 years ago or 3 years ago, and I'm getting back to the code and I'll be like, why did I do this? Why did I do that? But if there is documentation, it will guide me to tell me this is the reason, then you understand. Say, oh, okay, that can even further guide you to even improve the system, right? So that's documentation. Then we have some advanced topic on talk about software reuse, how you can reuse software system that you have built, use it, integrate it, and connect it to build more larger system, right? Then software and component-based system. We'll talk about cloud computing. Because when you build your system, you want to deploy those systems into the cloud, right? You have a lot of cloud computing. We have Azure. We have GCP, that's Google Cloud Platform. We have AWS, that's Amazon Web Services, and we have, last but not the least, that I love the most, OIC, that's OIC, Oracle Cloud Infrastructure, OCI. I mean, a lot of people don't really know about Oracle Cloud Infrastructure. So maybe I'll be taking some courses on Oracle Cloud Infrastructure, how you can use Oracle Cloud Infrastructure to deploy your systems. how you can use you create you create load balancers, you create servers, some VMs, set it up, you create some workloads, create your containers that are running. You create some subnet network, you create block storage, file storage, and block file, and and a lot of storage systems that you have in the cloud. So I'm going to be explaining on that. So Oracle Cloud Infrastructure is very, very good. I love what they do. Actually, I love what they do. So I love that. So like I said, there are many of them. You can, if any one of them you learn, it will give you foundation for the rest of them, right? It will give you foundation for the rest of them, right? So that's it. Then we move to security and privacy. Security and privacy is very, very important. When you are building a system, you want to make sure that the system is very, very secure. You don't want an hacker to break into your system and wipe your data or wipe the money in your system or commit fraud, right? So security and privacy, you need to make sure that your customer or the software system, the data the software system use is well protected, right? We will be talking more about that. Then we'll talk about ethics in software engineering. The ethics in software engineering, you need to make sure that you are not using the data of the system for your own personal interest. That's very, very important. The ethics in software engineering. You don't want to write a code that is malicious so that you can then break. So you don't want to do that. So there are ethics in software engineering, right? The ethics, the ethical standard you must follow. You also don't want to make sure that you don't you don't use the system to your own advantage or try to manipulate the system to gain advantage and do some dangerous thing. It is not very, very good. If you are going to work in any company and you want to survive, you need to make sure that you have a quality ethics, quality that you must follow, right? It's very, very important. Then project. So project also. So the last module, last phase will be our project, right? We're writing some projects, implementation and all. And yeah, so I think that's all for today, and I hope you do enjoy the class. And when next I'm coming here, we'll be starting fully on the module 1. And I want to say thank you for joining my my class today, and I wish you a happy new week. A happy weekend, and I'll see you in the next class. Do enjoy your weekend. Bye for now.